In this video, we will show how Validus integrates with your current design process. We will see how it gives you live feedback on potential manufacturing issues as they happen. Validus finds manufacturing issues in your part as it is being designed the same way that a spell checker detects spelling mistakes as you type a document or email. I will open a part to continue with the design. When it is opened, we see that the Validus indicators initialize themselves. In this case, the complexity indicator has already dropped down one notch. Looking at the results view, we can see what feature has caused this. We see that hole 3 has been created and that it exceeds the maximum hole diameter rule. I will now switch back to the Inventor model tree and continue designing this part. Notice that Validus does not make you alter how you create parts. It checks features as you create or modify them. Now let's put some holes through the middle of this part. As soon as these holes are created, the manufacturability indicator drops down one notch. I can choose to ignore this and continue modeling, or I can look at what was detected. In this case, we see that hole 7 has violated the depth to diameter rule. By changing the hole to ½ inch, we see the hole now passes the depth to diameter rule. However, ½ inch is too large for this part, so I need to reduce the diameter to 3/8 inch. This causes the failure to reappear. This part needs to have material cut away from the bottom. By doing this, I indirectly affect the depth of the hole. Validus recognizes this indirect change and recalculates the depth to diameter ratio for the holes. When the extrude cut is added, the depth diameter ratio of the hole is corrected. However, it has also detected that newly created extrude has produced some sharp internal corners. This condition can be corrected by simply adding a 1/16 fillet to the inside edge of the extrude. This part needs an inside counterbore feature added to the hole down the middle. When this hole is added, Validus detects some engagement issues with this counterbore. It also detects that the hole is flat bottom and larger than the maximum hole size. Both of these failures will be acknowledged. To correct the engagement issues, I need to reduce the size of the flat bottom hole. Alternatively, I could have altered the sketch points for the 6 holes to move them away from the counterbore feature. Because the diameter of the hole has changed, I need to acknowledge the large hole failure message again. Validus allows you to use Autodesk iLogic rules to create your own custom checks to expand on whatever is delivered out of the box. Here we see that a validate tapped hole rule is being executed every time a feature is created or modified. This rule is created to ensure only valid tap sizes are created. When we add a new tapped hole to this part, the iLogic rule is automatically executed. The results generated by that rule are handled the same as built-in rules. We see that the 1/4 inch 20 UNC tapped hole is a valid size. If I modify this tap size to something invalid, the iLogic rule is executed again and it displays an error message. A failed result is also added to the results tree. Validus produces a report that gives a summary of the checks executed on the part. At a glance, we see how many features passed, failed, or were acknowledged. The detailed information for acknowledged checks shows feature name and the rule that was broken. This report can be used in design reviews or to provide a heads up to the machinist of potential issues when this part gets to the manufacturing stage. I hope you have seen how Validus can enhance, not change your design process, and how it provides early detection of potential manufacturability issues. For additional information or to download a free trial version of Validus, visit www.digmfg.com.